So here we are going to discuss about the problems on Z transform and how to find it regions of convergence. It is mentioned as ROC. Okay, the first problem is what is x of n is equal to del of n. Okay, so if I take Z transform, so Z transform of x of n, it is equal to x of z, that is equal to summation n is equal to minus infinity to infinity x of n z power minus n. So this is a formula. So here we are going to substitute n is equal to minus infinity to infinity del of n z power minus n. So del of n is equal to 1 when n is equal to 0. For other values it is becomes 0. So if I substitute n value is equal to 0, z also becomes 0. So I get del of 0 z power minus 0. For the rest of the value it is 0, and it is 0 for other values of n. Okay, so the second write it as since the del of 0 is equal to 1, I will get 1. Anything power z or z power any z power 0 is 1. So you will get the answer as 1. So here the ROC is entire z plane is your ROC. Okay, so next second question, x of n is equal to 1 by 2 of n u of n plus 1 by 3 of n u of n. Okay, so here if I take the z transform x of z, that is equal to summation n is equal to, since I have u of n, you have to substitute 0 to infinity. X of n value I am going to substitute here 1 by 2 of n z power minus n plus summation n is equal to 0 to infinity 1 by 3 of n z power minus n. So this is equal to summation n is equal to 0 to infinity 1 by 2 z power minus 1 the n. Okay, that is equal to summation n is equal to 0 to infinity 1 by 3 z power minus 1 power n. So here the formula of, we have already discussed this formula, right? So the formula for this one is 1 divided by 1 minus c. Second, write it as 1 divided by 1 minus 1 by 2 of z power minus 1 plus 1 divided by 1 minus 1 by 3 of z power minus 1. So in this I am going to equate this denominator to 0. If I equate this denominator to 0, I will get 1 is greater than 1 by 2 of z power minus 1. So I can write z is greater than 1 by 2, right? Z is greater than 1 by 2. Likewise, if I equate this one to 0, I will get z is greater than 1 by 3. So we know that the 1 by 2 value is greater than 1 by 3. So I can write z is greater than 1 by 2. So why I am giving modulus is, so if you see here you have 1 by 2 value. Since it is a circle, so if I draw like this, you will get here this value is minus 1 by 2. So that is why I am giving the value as minus 1 by 2 and the modulus value. So this is the imaginary part of z and this is a real part of z. Okay, so since z value is greater than 1 by 2, so my ROC is like this. Okay, so why I am not giving the modulus of z is greater than 1 by 3 is the ROC should not contain any pole. Okay, should not contain any pole. So suppose if I draw it from minus 1 by minus 1 divided by 3, so you will have minus 1 by 2 value as a pole that comes inside this ROC. So you have to write the ROC, that is z must be greater than 1 by 2. So this is your value. So this is called as one-sided sequence, one-sided right-handed right? Right hand sequence, right? Okay. So, um, so it is always positive. It is always causal. Okay. So this point you have to note it down. Okay. So let us discuss about the two-sided sequence. Okay. So suppose the question they have given um, x of n is equal to summation 2 comma 3 comma 1 comma 2 comma 3. Okay. So here if you see, if I take the Z transform, I will get summation n is equal to, so this is 0 value, 0 minus 1 minus 2, right? So it is ranging from minus 2 to 2 x of n z power minus n, right? So you will get x of minus 2 power z power minus 2 plus up to x of 2 into z power 2 plus 2. So this is minus 2. So if I substitute for x of minus 2, x of minus 2 value is 2, right? So 2 into z power 2 plus 3 into z power 1 plus 1 plus 2 into z power minus 1 plus 3 into z power minus 2. So this sequence is called as two-sided sequence. Okay. So here the ROC is entire Z plane except Z is equal to 0 and Z is equal to infinite. Okay. So next let us discuss about left hand side. Suppose the question is x of n is equal to 3 1 2 4. Okay. And so this is called as left hand side left hand sequence. Okay. This is always anti-causal. Okay. So if I take the x of z is equal to summation. So it ranges from 0 1 2 3 from n is equal to minus 3 to 0, right? X of n z power minus n. So this I can write it as x of minus 3 z power 3 plus x of minus 2 z power 2 plus x of minus 1 z power 1 plus x of 0, right? So this I can write it as 3 into z power 3 plus z power 2 plus 2 into z plus 4, right? So, the ROC is entire Z plane except Z is equal to, so since it is left hand side except Z is equal to infinity. Okay. So if we see the positive so next we will discuss about the positive sequence also. Suppose if x of n is equal to 1 3 2 4, okay, and here it is a right hand sequence. I told you it is always causal or positive sequence, right? So this I can write it as x of z is equal to 1 plus 3 power z power minus 1 plus 2 power z power minus 2 plus 4 into z power minus 3. So here the ROC is entire Z plane except z is equal to 0. Okay. So next, seventh problem, x of n is equal to del of n minus 2. Okay. So x of z is equal to summation n is equal to minus infinity to infinity del of n minus 2 z power minus n. So if I substitute n is equal to 2, del becomes 0. So it has to be z power minus 2. So the formula is if z power m. So if the m value is greater than 0, then ROC is entire z plane except z is equal to 0. Right. So here you can see the m value is greater than 0, right? Because m is 2 here. So the answer is the ROC is entire z plane except z is equal to 0. If suppose m value is negative, means ROC is entire z plane except z is equal to infinity. Okay. So that would be your answer. Next, we will discuss another problem. The x of n is equal to minus 1 of n u of n. Okay. So what is my x of z? X of z is equal to summation, since you have u of n, it is from 0 to infinity minus 1 power n z power minus n. So I can write it as summation n is equal to 0 to infinity minus 1 z power minus 1 the whole power n. So what is the formula? 1 divided by 1 minus 1 z power minus 1. So this I can write it as 1 plus z power minus. So here we know that 1 plus z power minus 1 should be greater than 0. So I can write z power minus 1 is greater than minus 1. Okay, so this I can write it as 1 by z is greater than minus 1. So I can write 1 is greater than minus z. Right. 1 is greater than minus z. So since I have minus here, right, I can write it as z must be greater than 1. So the next problem is x of n is equal to b power modulus of n. So the second write it as x of z is equal to summation n is equal to minus infinity to infinity b power n z power minus n. So n is equal to minus infinity to 0, right? This becomes minus n, right? Minus n, and from n is equal to 0 to infinity, this has to be positive, right? So this I can write it as so not to change, sorry, first write minus infinity to 0 b p power minus 1 z power minus 1 whole power n plus summation n is equal to 0 to infinity b z power minus 1 whole power n. Okay, so I need to change this one, right? So I can write it as n is equal to 0 to infinity. So in order to make this one infinity as minus infinity as positive, I have to change this n to minus 1. So if it goes inside, it becomes b z power n, right? since minus 1 if I get it inside, so otherwise I can write it as okay, this is correct only, plus summation n is equal to 0 to infinity b is a power minus 1 the whole power n. So you apply the formula, you will get 1 divided by 1 minus b z plus 1 divided by 1 minus b z power minus 1. Okay, so here if we equate this one, 1 minus b z power minus 1 greater than 0, I get 1 is greater than b z power minus 1, right? So z is greater than b from this equation. And if I equate this one, 1 minus b z is greater than 0, I'll get 1 is greater than b z. So 1 by b is greater than z. Okay. So I can write it as 1 by b, which is greater than z, and z is less than b. So that is your option. So here b may be, so they have given b is as modulus of b. So which means it may be a positive value or negative value, whatever it is. So definitely it becomes less than 1 means it may be 0 0.1 like that only, right? So I can write it as modulus of b. Okay. So the given problem is x of n is equal to sine omega naught n u of n. So I can write x of z. X of z is equal to summation n is equal to 0 because I have u of n infinity sine omega naught n z power minus. This sine I can write it as is n is equal to 0 to infinity e power j omega naught n minus e power minus j omega naught n divided by 2j. So this is a formula for sine omega naught n minus. Okay. So from this I can write 1 divided by 2j and taking it outside, summation n is equal to 0 to infinity e power j omega naught z power minus 1 the whole power n plus 1 divided by 2j summation n is equal to 0 to infinity minus of e power minus j omega naught, right, z power minus 1 whole power n. Okay. So from this I can write it as I can apply the formula, right? So 1 divided by 1 minus e power j omega naught z power minus 1 plus, so this minus will come outside, so you can write it as minus 1 divided by 2j. Okay, 1 divided by 1 minus e power minus j omega naught z power minus 1. Okay. So from this I can take the common term, both are same. Okay, so if I take 1 divided by 2j outside, and you can write 1 minus e power j omega naught z power minus 1 into 1 minus e power minus j omega naught z power minus 1. So this I can write it as 1 minus e power minus j omega naught z power minus 1 minus 1 plus e power j omega naught z power minus 1. Okay, yes, here the 1 and 1 get cancelled out. Okay. So here I can write it as 1 divided by 2j So if I take z power minus 1 common, I will get e power j omega naught minus e power minus j omega naught. Okay, divide by. So if I cross multiply this one, 1 minus e power j omega naught z power minus 1 minus is e power minus j omega naught z power minus 1 plus e power j omega naught into e power minus j omega naught z power minus 2. So e power j omega naught minus e power minus j omega naught divided by 2j is nothing but sine omega naught, right? And so here 1 minus I can take z power minus 1 common, right? So I'll get e power j omega naught plus e power minus j omega naught. These two get cancelled out, so you'll get z power minus 2. So here this the formula for the cos omega naught, right? So what is cos omega naught? So 1 minus so cos omega naught formula is e power j omega naught plus e power minus j omega naught divided by 2. So we'll get 2 z power minus 1 cos omega naught plus z power minus 2. So I hope this video is useful for you, and the region of convergence values greater than 1. Okay, thank you.